We now have a session, Trust Under Test, Advancing PAD for Governments. This will be a panel discussion discussing the role of presentation attack detection in government ID systems, spanning technical realities, field lessons, standards, maturity, and practical adoption pathways at national scales. Can I please invite Ted Dunstone to moderate the panel? He will introduce himself and his panelists. Thank you.
Thank you all for coming to this session. We've got an amazing panel and a lot to cover in a very short time, especially if we're to keep within our time limits. I'm Ted Dunstone. I am here representing the Biometrics Institute. There we go, Biometrics Institute. And I will tell you a little bit more about the work that the Institute is doing in this area in a moment. I also am the chair of the Biometrics Working Group for MOSIP, and I also run a biometric testing lab called Bixi Lab. So can I invite the panelists up to the stage, please? As I mentioned, we have an amazing panel here with great diversity of experience, and I would absolutely love to get some interesting questions on presentation attack detection from the audience. So when you're listening to people talk, please have some good questions to ask at the end. So I'm going to start with a very quick sort of introduction to PAD, and then I will hand over to our panelists. I'll get them to introduce themselves and their affiliations, but as I mentioned, we've got Jay here from FaceTec. We've got Digvijay from Next Biometrics. We've got Henrik at the end there from Precise. We've got Arun from Michigan State University, and finally we've got Roberto from AIT. Just would start with a quick introduction to the Biometrics Institute, and I'll link this to presentation attack detection as well. So the Biometrics Institute is an organisation which has been running for over 25 years. In fact, this is the 25th anniversary year of the Institute, and it's made up of governments and vendors and other interested parties from around the world who come together to share their experiences, not unlike the work that happens in MOSIP, but the work that the Institute does is very much based a lot around policy, a lot around new developments that are happening in the biometrics industry. And so I would encourage you to go and have a look at the website. One of the things that the Institute has been pioneering is what we call the best practice framework. And the best practice framework includes the whole life cycle journey of the best practice for when one is implementing biometric systems, especially large-scale biometric systems, including things like privacy and deployment and all of those things that can turn out to be small parts of your plan, but could turn out to be big headaches when you go to implement. And part of that, of course, is presentation attack detection, liveness, and testing. One of the things that the Institute is just about to put out, actually, is a new diagram. One of the benefits of being a member of the Institute is that we do explanatory diagrams. And so we're just about to put out a new diagram on presentation attack detection. For those of you that might be a little bit new to this area, these diagrams are great because they try and distill a whole lot of complex jargon into one particular diagram. Obviously, in that simplification process, sometimes there are lots of arguments that happen about what needs to be in and out. But in the end, we've come up with what we think is a really good diagram. When we're looking at the use of presentation attack detection, or often known also as liveness within a government type context, traditionally this hasn't been something that has been a major focus of MOSIP. And one could ask why that is. And that's because a lot of the initial work in MOSIP has been very focused around the enrolment component. Where you are dealing with enrolments, you're often dealing with in-person, and it's actually a lot harder for people to defraud systems. Certainly not impossible, as we heard this morning from Uganda, but there are certainly less avenues. But now that we're looking to use these digital credentials, and that means that they can be used in self-services, they can be used in all kinds of different ways, there are all sorts of avenues for people to try and break through and incentives for people to break systems. So it's really important now that presentation attack detection is incorporated, and there's a whole series of work that's happening inside MOSIP, which is starting to codify the way that will work. And I don't have time now to go into that in great detail, but certainly you should expect to see some work that's coming out of the work group on standards, on how that will be integrated within the secure biometric interface standard. So I think we would widely recognise that we're in an era now where the old kinds of protections, which often were based on maybe knowing that your attackers didn't have information about how your system might work, with more advanced AI coming out, whether that's deep fakes, whether that's just traditional AI looking to find different ways of exploiting your systems, any of these systems are just going to really have to up their game, because your base level attacker is going to have access to so much more information, so many more tools that they're going to be able to use to exploit your system. And this is actually one of the huge benefits of MOSIP, because a lot of really great work has already gone in to building a secure platform. But that platform is going to be tested, and one of the ways it will be tested is through the presentation attack detection, people producing masks or fake fingers or all sorts of different methods that people can use to circumvent the systems. So that's enough from me. So I'll ask each of the panelists to give a 5-minute presentation just explaining a little bit about what their organisation is involved in this area, and also the key messages that they would like people to take away in terms of presentation attack detection and how it will affect governments into the future. So we'll start with you, Roberto.
Yeah, that's all right. I can start?
Yes,
yeah.
please.
Roberto Levya from the Alan Turing Institute in London. So I mainly focus on the face biometrics. So for the past 5 years, we're spending time on particular face technology, imbalances, detecting the face in the right context, and of course doing deepfake detection. So, only the latest of our research is that we noticed that this progress of deep learning in AI generated faces is a real concern, as Ted mentioned briefly, because some few years back, you need real data to create, for instance, generated data, but it was real data with real data processing. But now with this technology, we have fake data that mixes with real data. So you can have a very serious attack, for instance, when you create a single face with real people and synthetic data. So basically, the attacker now has the ability to create many identities with one single identity. So that's evolving fast. So we come to realize that creating models where we show the synthetic data, the attack, the deepfakes, and also the real data is getting more complicated because the models are getting so quite big. So it's necessary to learn from the real data distribution. So that's what we're working, because there are so many ways to create synthetic data, fake data, fake faces. So we're concentrating in models that they use more the reference data, that the one you can trust to detect some of the deep fake attacks. So this what we're doing for the past 2 years, mainly concentrating in that particular technology. And our advice for governments and organizations is this evolved really quick. So we notice how it's very simple to create so many attacks. So it's very dangerous because the entire system is compromised when one single sample might bypass the system. So that's, well, you to be concerned that this deepfake technology is causing so much disruption in this particular field of synthetic data.
Thanks, Roberto. Jay.
Hi, everybody. I'm Jay Meier. I'm the Chief Identity Technology Strategist at a company called FaceTec. FaceTec is the global leading provider of three-dimensional face liveness and biometric matching software. We are an OEM software vendor. Our customers and partners embed our software into their apps and then again behind their firewall in their server system. We are going to do something like 4.4 billion liveness sessions over the next 12 months. Our SDK has been downloaded almost 1.5 billion times, and it's being downloaded about 3.5 million times a day. We have gone through extensive third-party testing, including with Ted over there at Bixie Labs. And we're very proud to say that our technology works extraordinarily well, both in preventing deepfake injection attacks, but also presentation attacks, and our matching is extraordinarily accurate. So I'm glad to be here and look forward to your questions. Thanks.
Thanks, Jay.
DJ. All right. Hello, everybody. I'm DJ. I'm from Next Biometrics. We are a Norwegian semiconductor company. We make fingerprint sensors. The way we are a little bit different is our technology is based on thermal as opposed to optics or capacitive that you see in general. That just because of science gives us a little bit edge over liveness detection because we are detecting the differential of temperature within the fingerprint itself. We've shipped like almost 10 million sensors now. We've got 2 different certifications with Aadhaar, MOSIP, and FBI and PIV and others. And we are seeing on ground what PAD is. Right? We encounter, and they come up with very different nomenclature for PAD. They started calling it spoofing initially, hacking. By the time it lands up with a guy who's making a fake finger for $2, it's called copy now. So they just say, okay, make me a copy. And so they go and they make these copies. I actually have a video which we probably can run if they have that. I would love to show you guys how it actually happens. And
Yeah, they said that they had the video queued, so
They have?
They have.
so, so in general, what happens is that you would, these fakes, right? Okay, so I'm only trying to show the, okay, you can see there's this one device, it's biometric. That guy's got a fake finger on there. Authentication successful. This is Hyderabad police, which caught them. These 2 gentlemen don't look like engineers. They got multiple of these fingerprints, which they are there. Yeah, that's it for the video. So what I wanted to actually show with this is we end up facing the real world challenges of once it's been deployed, people are started using it. It's not going to happen that people are pulling fingerprints from a glass as they show it in a movie. That's not happening. These are collaborative spoofs. People are going to places and saying, hey, I want a copy of my fingerprint. I need it because I don't want to give attendance. I want somebody else to do it, right? And there's, so obviously the system has to be robust enough, and which is it is, and people do realize it fast enough. And we had to go through a whole, they upgraded the algorithm and the fingerprints and so on and so forth. So there is work around that side. One thing I would want to point out is because there are so many different materials which keep on getting used for spoofs, we have to, as as total as an ecosystem here, we have to figure out a way of finding the problem, addressing it, making a solution, and going back to the market quick enough, rather than going for a very long and delayed process of getting those devices certified again across the world, right? The faster this process becomes, the faster the government is able to deliver those services, the faster those devices go out in the market, and we are able to. But if this process becomes longer, then everything else suffers down the line. So, yeah. So so my only point would be to, the attacks are only going to become more now. Now that it's being installed across, and we are seeing it everything from US to Brazil to Africa, everywhere. We're seeing these attacks coming up. People are becoming smarter. We obviously have to be one step ahead. And that way is that even in this room, we've got intelligence from all across the world. We need to pull in, figure out what's the best way forward, and then keep on deploying that. That's my take.
Thanks,
Thank you.
Arun.
Thank you, Ted. My name is Arun Ross. I'm a professor in the Department of Computer Science and Engineering at Michigan State University. I also serve as the site director for the NSF Center for Identification Technology Research, where we have a consortium of universities working along with industry and government agencies in the United States. So the topic that I'd like to very briefly introduce you to is a research project that we did with an organization called IARPA. That's Intelligence Agency Research Project Activity. The name of the program was Odin, and the focus of the program was on detecting fake fingerprints, fake face, and fake iris. So fingerprints, face, and iris. In fact, there is a video here that will showcase the face modality, although we have similar solutions for fingerprint and iris. So you will notice here a person interacting with the smartphone. If there's a green box, it's a live bona fide user. If there's a red box, then that would be a fake, say for example, a mask or the application of makeup, and so on. So this, of course, is a live face, and as we bring in other types of modes of attack, the color should change to red, indicating that a spoof attack is being launched. So the focus of this program was on also the training data. And when I say training data, I'm not talking about training a human examiner, but training the machine learning algorithm. And one of the major lessons we learned in this program is the importance of using this training data in order to train what we call as these massive neural networks. And our research highlighted the importance of collecting data and also the importance of developing solutions that can detect attacks that have not been conceived, that have not been seen in the lab setting. So really, this was a very interesting program, and I'll be happy to take questions. Face, fingerprints, and iris, those were the three modalities, and primarily the solution was using these large-scale neural networks with massive amounts of training data.
Thanks, Arun. Henrik.
Okay. Hi, everyone. My name is Henrik, and I work with Precise Biometrics. We are very happy to be here and talk about national ID and the biometric security in this area, because we have, basically 20 years of experience within different kinds of presentation attack detection. We have been working mainly with the mobile phones, the smartphones. And if you talk to our marketing department, I think they will say that we are protecting about 100 million smartphones today. So what we have done is that we have taken our algorithm and make sure it can run in a much more limited hardware environment. And why is that important? It is because you need to comply with the ISO standard when it comes to PAD. It's supposed to run on the edge. The analogy between mobile phones and national ID is that on the mobile segment, you have seen that you get access to much more services. It could be healthcare services, it could be different digital wallets, it could be, I mean, all your personal stuff. And of course, you know, the mobile phone needs to be protected against any kind of spoof attacks. And I see that this is the same kind of evolution that will happen within national ID. So I think from my end, I would say there are three aspects that should be considered. I mean, first of all, you need to take this as an infrastructure question. You need to look at, okay, how can, for instance, MOSIP standardize, you know, what kind of test you should do, like Android is doing for the mobile segment. So that is one aspect. A second aspect is, like DJ was talking about, is the deployment, because this is like a virus and antivirus battle. You know, there come out new attack vectors, so you need to have the possibility to take the new attack vector and quickly deploy a new solution out to the market. And I can just say, I can only speak for fingerprint because I don't really have any experience in face as such, but the fingerprint is definitely our home turf. And then the third aspect is the user experience, because when you create this super safe anti-spoof solution, the risk is that you really don't let the correct people in as well. So this is just a statistics in biometrics that what is called a spoof accept rate should be very low, but at the same time, if I enter the system, I mean, I'm supposed to enter the system should let me in, of course. So that's a matter of a user experience aspect, because if I need to try my finger several times because there is high security, yeah, that's not a good user experience. So those three aspects, I believe, are very key to bring into this national ID program. Yeah.
Fantastic. Thanks for that. I think they were all very, very interesting perspectives. So before I ask some questions, we've got any questions from the audience? Oh my goodness, I asked you guys to think of something. Oh, fantastic. Please.
Hi. Yeah, so we've talked a little bit, you guys talked a little bit about face and about fingerprint. And so I'm wondering, I know this isn't convenient for, picking out a particular person to answer, but I'm wondering about pad between the two. Is one significantly more advanced than the other, or are there particular considerations that make one, much more difficult than the other? And we haven't heard anything about iris, which some of these systems are also national systems are using. And so is there anything on that modality that we should keep in mind for PAD?
This is just a follow-up to his question, and
Yeah.
it'll be great if you can add a layer of active and passive aspects of PAD and how you really go about it, and how does the technology that you apply differ across?
So Chris's question was not product specific, but yours is. So I'll try and talk to Chris's question first. It's important to remember that the standards for presentation attack detection and also for deepfake injection attack detection, the standards are really about how you test for these things, not specifically what is tested. So for example, one lab, we've used Ted's lab a couple times, and he does a great job. He has very sophisticated tests that he can use to attack our systems, right? And in fact, you don't want the organization that's being tested to know what the attacks are going to be, because after all, in the field, you don't know the level of creativity that an attacker might have. So there are levels, measurements of levels of attack, and you need to ensure that the independent test lab is sophisticated enough to incorporate sophisticated attacks, because they could be certified. You could end up certified only at a very low efficacy level, which doesn't do anybody any good. In terms of, to your question, and I'm sorry I didn't get your name, but at FaceTec, we like to boast that we are the only biometric vendor in the history of biometrics that has ever stood up our own spoof bounty program, a bug bounty program. If you go to spoofbounty.com, you can enroll and start attacking our system as it is today. And if you are able to disrupt our system or break in, we'll pay you up to $600,000 US, okay? We've had that up and operational for about 5 years now. We've had over 150,000 distinct attacks, including attacks from many of our competitors, and they didn't get in. And we did pay out twice early on, but it was such a low-level attack that the payment was negligible. And of course, it's the best research and development that we can ask for, because we get to see what they did. We were able to close the vulnerability, and we haven't had any more breaches since. So, and you asked about passive versus active in face matching. First of all, there's different definitions out there of what's passive and active, okay? The National Institute of Standards and Technology in the United States defines passive as any type of defense that requires a command response type of an activity. So turn your head to the left or right, cough, whatever it is. And passive does not require any type of command response. There's no instructions for somebody to follow. Of course, active attacks today are very vulnerable to advanced AI attacks. The technologies that even teenagers can get for free today can mimic a human face and a human response. You can't tell that it's not correct. So an active spoof attack or spoof response can be spoofed quite easily. We recommend at FaceTec what we call passive, which means we don't use any command response, and our technology uses three-dimensionality, and we work on any smartphone. A human face has to be three-dimensional, or it's not a human face. So if we can determine two-dimensionality, we know that it can't be a human face, right? But we also use over 70 what we call involuntary human cues, which are things about your face and that you have no control over. So for example, the dilation of your pupil is involuntary. You have no control over it. Well, our learning engines have picked up on over 70 of these types of things that it measures independently. It's very hard to attack when you don't know what is being measured. And importantly, it's even harder to attack when you don't know the order in which those measurements occur. So if it's pupil dilation versus something having to do with your skin, it has to be in that correct order. And so we've effectively randomized the attack, which is critically important. And of course, we can talk about deepfake injection attacks, but this is about pads. So I'll be quiet now and let somebody else share.
So I'll talk about IRIS. So in fact, the IARPA Odin program that I mentioned earlier did have IRIS as one modality. So one of the challenges in IRIS in that situation had to do with cosmetic contact lenses. These were contact lenses in which there were textured patterns. But in some cases, obviously you don't want to flag someone wearing a prescription contact lens. And these cosmetic contact lenses, as it happens, is created differently in different parts of the world. And so there are different types of manufacturing processes that would impact how these textured cosmetic contact lenses would look like. Our algorithm did work well on those types of attacks. And if we were to look at the report coming from IARPA, you will notice that Michigan State University actually came first in that competition. So our algorithm worked well, but I must say that working with cosmetic contact lenses was not very easy. And if I can quickly add to the second question about active and passive, as part of the IARPA program, we did try both active and passive, and as Jay rightly mentioned, sometimes the passive method does not make any assumptions, so it has to really glean some information from the image. But we did try multispectral lighting in the case of face and iris to see how they would respond, or how the images would respond to variations in lighting for bona fide images, bona fide faces versus spoof faces. So those are some comments along those lines.
Yeah. Chris, I'll actually address your point around why earlier nobody spoke about the iris pad part of it. I think so it's got directly related to the amount of deployment of devices versus what are you going to gain from spoofing the system. Right now, invariably we have seen the deployment of fingerprints a lot. We are going to see more that means the pad attacks are actually happening on fingerprints because it's more readily available. People can try different kind of materials and then they can test it. Face becomes more difficult in the sense the deployment till now has not been that much. Iris even further lower. But as soon as one tech gets deployed a lot, and then the advantage or the return on investment on doing that attack increases, you'll start suddenly seeing face attacks. Like, of course, I think so all of us, one of the first things that generally in the biometric community you do is you try to hack the other system, right? And I guess most of the people have started with hacking the iPhone Face ID, right? That's where they started off from, and then goes beyond. And once you figure out that but how much time did you spend to hack it? Was it worth it? What were you able to get out of it? So that's why you'll see the number of attacks there lesser. But my hunch is as soon as Earth's technology gets deployed across furthermore, you start seeing hacks there. Initially, it appears, it's not going to happen. It's really safe. It's not safe. People have just not spent time on it. Give them time, give them resources, they will figure out a way. So, and that's why we have to be a step ahead and we have to keep on evolving. So that's why, yeah.
Thanks. Yeah, it brings to mind one of the big attack surfaces we always thought was bored students. Got a whole lot of time on their hands and access to equipment. But actually, DJ, point you were making before, which is relevant. So if you're trying to attack somebody, one of the things you need is the source biometrics, right? And so your face biometrics are much easier to collect than fingerprint or iris, which means, of course, that if you're using face, having pad is very important because it's so easy for people to get access to the source. And so, when we're doing attacks as a lab, we're very careful to distinguish between those attacks that are cooperative, so what you talk, and uncooperative attacks, because they have different risk areas. Yes, Jake?
Could I just make one more comment to that question? When you're testing for presentation attacks or spoof attacks or anything like that, you have measurements like a false accept rate or a false reject rate, right? A false accept rate means did the wrong person get in? False reject rate means was the right person refused, right? And I know that's not the language that we use, but Ted will tell you all about the language. But one of the things that I want to point out is that when you are evaluating liveness capabilities and biometric capabilities generally, I'm not talking about face or any specific one, it's critically important to set your false accept threat ratio as low as possible. In fact, you want it at 0. You cannot allow yourself to experience one single successful attack. And the reason is because once the attacker finds the one attack that works, they will use that same attack thousands and thousands of times. They will that's the only attack they need because it works. And so your false accept rate will go from, something small to something very, very large very quickly, and they will spread it to all of their friends. And so that vulnerability will become public knowledge, right? So at FaceTec, one of the things we do is we set our false accept rate to 0. We will not accept a false accept rate higher. Of all the known attacks that we are aware of, we won't accept. We set the threshold so difficult that nobody can get through. Because once they get through, they will use that attack over and over and over again. Make sense?
Let's say false negatives because of this, and it may lead to, especially in the context of ID, it may lead to exclusion of a few people. Do you see instances? Is there a trade-off that you see between, let's say, enhanced security and inclusion exclusion?
I'm going to answer this quickly because I don't want to dominate the whole conversation. You're right. We would prefer that we have no exclusions, that nobody is asked to present twice, right? When our system detects an attack, it doesn't say this is an attack. It just says, oops, something went wrong. Try again. And so that person has to try again, right? And rarely, unless it is a bona fide attack, it just doesn't happen with our system. Our system is extraordinarily good at what it does. But false accept rates, you need to keep them at 0, which means you need to accept some false reject rate. And it's really not about exclusion at that point, because the number of people don't get excluded indefinitely. They just can keep trying, right? So it's an important question, but the nuances are extremely important. If you allow one attack success, you will allow thousands of attack successes. So there's a trade-off there.
You've got time for just one more reply.
Yeah, I just want to comment on that. From a fingerprint perspective, we actually have 3 biometric KPIs. I mean, you have the false accept rate, which means that someone is very like you that actually gets into the system, and then you have the false reject rate. But what I spoke about before is the spoof accept rates. That's the 3rd KPI. And I think that there is always a threshold between the false accept and the false reject. But the thing is, when you start protecting for spoofs, that is actually, I mean, my finger, I'm supposed to get in, but then at the same time, I'm supposed to protect against things that actually looks like my finger. So when I spoke about the user experience before, is that is the, in my opinion, that is the most important balance between the false reject and the spoof accept when it comes to presentation attack detection. And I know also that from the mobile industry, some of the tests, when you do these kind of BCR tests or what have you, you actually don't test the false reject at the same time as you test the spoof accept rate, which means that the final testing will not be really adequate. So I think that is also one thing that you need to do. You need to test both of these, because if you get a very high false reject rate, then again the user experience is crap, and the system, no one wants to use it.
Yeah, I couldn't agree more. It's that separability of both of those. I mean, obviously you can test a system end to end, but to really understand how a system's going to perform, you really do need to have both metrics, and they compound, of course, because if you've got errors in one system and you've got errors in the other system, your total errors are both of those. But I'll share a story I had when being out in the field in a country in Africa, looking at the enrolment process, and these people had travelled a long time to get here, maybe days even to get in, and the system that was being used, they had real trouble using it. The person who was doing the enrolment was obviously annoyed because it was hot and they had to do lots, and there was this poor lady who was subjected to, 10 minutes worth of positioning this equipment to try and get her past this point. As we heard this morning with the Ugandan lady who said that, falsely identified a mask. It was a similar sort of situation. So that person was accepted, to Jay's point, like the transaction was successful in the end, but it was very unpleasant and unnecessarily difficult. So I think that goes to the heart of the inclusion question. You know, people want to be able to use these systems and use them in as simple fashion as they can. Yeah.
I think it's worth noting that unlike cryptography, biometrics are a statistical probability calculation. You can never have a perfect score over the long period with biometrics. So you can only raise the confidence rate as close to perfect as possible, but you can never hit perfect. So there is always going to be an error one way or the other, and you have to decide how you want to balance those errors out.
All right, well, I've been told we've got, yes, please, got a time for one more question. Yeah.
You have been talking about anti-spoofing, fake finger detection, FAR and FRR. So my question is, do you see any standard emerging that maybe in near future could become mandatory for national ID in order to prevent from this kind of attacks?
Yeah, that's a great question. I might take that to start with. So the ISO standard 3107, part 3, which basically defines the attack testing protocol, is, I think it might have been Jay, was saying basically it's not prescriptive in terms of the types of attack. It talks about the methodology and the reporting. And then on the other hand, you have FIDO, which provides actual pass-fail and provides more granularity around that. But I do think it's something that needs more work, and there needs to be better standardisation. And that is something that within MOSIP, there's a program which is going on to address exactly that particular issue. So yes, I can't give you a time frame, but there will be a point at which, from a MOSIP perspective, there will be tests that are specifically dealing with national ID style deployments and what should pass and what shouldn't.
But there are already countries that are deploying it. So they are coming up with different systems, right? They are coming up with very specific tests only for fake finger detection or liveness detection, whatever you want to call it. They will set aside, all right, these are the 22 materials that you got to use, for example, right? So yeah, I actually do see different countries and different systems try to come up with different modalities or different ways of testing specifically for their core audience or people. And eventually, I agree with, I think so. A time is gonna come that they're gonna standardize that as well. But as of right now, yeah, different regions are trying the different stuff.
Keep in mind that the testing protocols, if you listed all of the attacks that were in a testing protocol, vendors couldn't tune their systems to those attacks, okay? It's critically important that we don't have a listing of specific attacks that you pass, because it creates complacency. You don't know what you don't know. And so if I had 100% A+ score on a test that didn't include a modern attack, I could get spoofed without even knowing it, right? The other thing you have to remember is that standards, especially at an ISO level, have a lifespan. An ISO standard cannot be changed except once every 5 years. So if you set a performance standard around in an ISO system, that standard can't be changed for 5 years. But the attacks evolve daily, right? So the one thing you can do is evaluate for overall performance, right? And then because defense performance, will continue to improve over time. And if TES does his job well, we will have systems that are really good at the most modern attacks.
If I could quickly add as well, it is a cat and mouse game. And so there is no end to this at all. In fact, more recently, for some years now, researchers have been viewing the problem differently by saying, can we model what is a true fingerprint, what is a live fingerprint, what is a bona fide fingerprint? Everything else is suspicious. So there have been lots of paradigm shifts even within this field, just because we don't have a finite count of attacks. And even if we did, as Jay rightly pointed out, we don't know what's out there.
Yeah. And the other point I'd make too is you don't want to create a recipe book for attackers, and that's one of the big challenges here. We collect, because we have lots of different clients, and many in the financial sector, for instance, we see what's coming through, right? But those things we can't really share, even though we know what they are. And of course, it's helpful as a test lab, but I don't think anybody's really cracked the best way that we can communally defend, whether it needs to be something that's a secret that's only shared communally between test labs, or I don't have an answer yet, but it is something that I think we're thinking about, and I think Arun's right. There are other approaches as well that can be taken to this problem. Jay?
All biometric vendors should be required to have their own spoof bounty program. They need to stand up and attack, and so we won't be the only one for very long.
Okay. All right, I think that brings us to a close. Can we thank the panel, please?